Hey guys, I'm going to do a quick tutorial on exponential functions. We're going to talk about what it looks like, what some characteristics are, graphing it, stating the y-intercept, stating the domain, and stating the range. So this is what the equation looks like. It's y equals a times b to the x. B is the base. It's what's got the exponent on it. So as long as you have x as the exponent, it's an exponential function. A can't be 0. If a were 0, then we'd have y equals 0, which is just the x-axis. So it would no longer be an exponential function. B's got some rules as well. Okay, b has to be greater than 0, which are just telling us that it's got to be a positive number. And it can't be 1. What this means is this a value here is the initial amount once we start looking at word problems. B is how much is this increasing or decreasing? Is it going up quickly by, say, multiplying by 4, or is it going down by multiplying it by 1/2 or 1/3? And again, you can see some of those examples in another video I'll do with word problems. All right, so first we're just going to talk about how to graph this equation. So I'm going to look at an example. Let's say y equals 7 to the x. It is an exponential equation because of the x being the exponent. So the way that we graph these, of course, you could cram it into a calculator, a graphing calculator, and look at it. You can graph it on Desmos, or you can do it by hand, which I think doing it by hand kind of shows you a little bit where these numbers come from. So I tell my students to pick a negative number, 0, and a positive number. So today I'm going to pick -1, 0, and 1. It doesn't really matter what numbers you pick. Just be careful when you plug it in. You're going to get really big numbers or really small numbers, and you want to make sure that you scale your graph so it'll fit. So if I plug in a -1 into this equation, I get 7 to the -1 power, which is 0.14. And it's easier to look at this decimal value versus a fraction in order when we get to graph it. Plug in a 0, 7 to the 0 power. We've studied exponents, so we know that anything to the 0 power is always a 1. Plug in a 1, you get 7 to the first power, which is 7. So in order to graph this, I'm just going to draw an x and a y-axis. I'm going to look at my table and see that my biggest number is 7. So I want to make sure I do to 7. And that's my y value, so I really just got to make sure my y value is to 7. I don't have any y values that are negative, so I really don't even need to do any negative y's. Okay, so when I go to graph, I've got -1 and 0.14. That's just up off the off the x-axis just a little itty bitty bit. 0, 1 is there, and then over 1 and up 7. 1, 2, 3, 4, 5, 6, 7. So about here. So exponential functions are curves, and they do extend in both directions. And it almost looks like it flattens out here and becomes a line, which it doesn't. What it's doing is getting super, super, super close to 0, but it's never going to touch it. And so we always talk about some value that could possibly pop up here. In my next example, we'll see a number here. So there's nothing here, so it's understood to be a 0 there. So we're approaching 0, which is my x-axis. So my graph is going to get super, super, super close to my x-axis but never touch it. And of course, in my Math 2 class, we talk about that being an asymptote. My Math 1 class, we talk about it being my electrical fence. We call it K. K is my electrical fence. We don't want to cross it. We don't want to touch it. We want to get super, super close to it, but definitely don't touch an electric fence. You'll get shocked. And these things don't curl back up. It's not a parabola, so it's not going to come winging back up. It's just going to get super, super, super close to it. And gradually, it almost looks like it touches it, but it never does. So then we're going to talk about the y-intercept of an exponential function. Of course, we can find any y-intercept of any function by plugging in 0 into the equation, which we've already done. If you look at the table, I've plugged in 0 right there. So that's my y-intercept. And of course, graphically, you can look and see where your graph touches the y-axis, which it touches it right here, which is also 1. So 0, 1 is my y-intercept. The next thing we talk about with functions is stating the domain and range. What domain values would satisfy this equation? What x values? Well, I can plug in any x into this equation and I'll get something back. And so we call that all real numbers. So you can write it out, all real numbers. You can use the fancy R. And some people will do negative infinity to positive infinity. It just depends on what book you're looking at. It depends on what internet resource you're looking at. It just depends on what you're told to write, how you're told to write it. So I tell my students fancy R is good enough for me. Negative infinity, positive infinity works as well. So that's how you state your domain. Your range talks about your y values. What y values satisfy this equation? Well, if you notice my graph, there are no negative y values. Everything is sitting above this k value of 0. And so we know that my y values are going to be all greater than 0. It never touches 0, so we definitely don't want to put an equal sign there. So it's greater than 0. Any y value that I'm going to get back when I plug in an x will be greater than 0. It's going to be a positive number. So that's it. 0 gives you your y-intercept. Your domain is always all real numbers for any exponential function. And your range is going to be based on this electrical fence I call K, or an asymptote, depends on who taught you. So that's greater than 0. All right, let's take a look at another example. Let's take a look at y equals 1/2 to the x, and let's do a minus 1. So this one actually has a fence value. This one didn't have anything there. Remember, I added that plus 0. So we remember that that's my electrical fence. This one's got a fence value, an asymptote value, a k value, however you want to call that, but it's a -1. So we'll have to think about that when we start graphing. So I'm going to make a table of values. And again, pick a negative, a 0, and a positive number. My students always decide we're going to continue with -1, 0, and 1. It's easy to remember, so you don't have to think about other numbers. So when you plug in a -1, and you simplify this entire equation with the -1 here, you end up getting a +1. And you can plug that into a calculator and do the math, order of operations, or cram the whole thing into a graphing calculator or Desmos, and you'd get you'd get +1. Plug in a 0, do the math, you get a 0. Plug in a 1, do the math, you get a -0.5. So again, when I go to graph this, I just look, see my biggest number, it looks like a 1, so I'm going to make this really spaced out. We don't need that many values. That's my x-axis, my y-axis. Label, label, label. Very important. So -1 to the left and up 1. 0, 0. 1, and then down this point, -5, this -0.5. We're just going to go down between 0 and 1, right there. Almost looks like a line, but when I throw my fence in here, my k value, which is here, I'm just going to draw a little line. You can do a dotted line, you can highlight a line, something that kind of indicates you're not going to go past this. This is my k value, it's a -1. So I know an exponential function is a curve. So I'm going to connect my 3 dots with a curve that approaches that k value but doesn't touch it. So that's what my exponential function looks like. It's definitely not linear. It's got a curve to it. And if I would have picked some bigger numbers or more negative numbers, you'll see that it shoots up fairly quickly on this side, and then it's going to come down and get really, really, really close to -1 but never touch it. So that's what the graph looks like, and you could, of course, put that in Desmos, or you can put that in a graphing calculator if you had one, and you can compare your graph to make sure it's done correctly. All right, and again, my y-intercept found by plugging in 0 for the x, so you can get that from your table of values. You can get that from your graph. You can see where it touches here at the center. My domain is always all real numbers. You can use that fancy R, negative infinity to positive infinity. Doesn't matter what x you choose, you'll get something back. My range values, this one's a little bit different than what we've done before. This one is, it's not that much different, but it is approaching my fence value of -1. So of course my y values are all bigger than -1 because it's sitting above that fence. So we say greater than -1. Sometimes you'll see graphs under your fence, and if it's under your fence, you would say less than. So if your values fall under that fence, that's because they're all smaller than that fence value. So the only thing you have to remember is fence goes here, all real numbers, 0 from your table, whatever this number is your y-intercept. And then of course you can pick 3 numbers to graph it. You can pick more if you choose, if you needed more dots to see your graph clearer. But that's basically what an exponential function looks like graphically, how you find the y-intercept, domain, and range, and that is all. Thank you.